In Chapter 6, we'll be finding the Hamming distance, which is counting point mutations. And this distance is named after Richard Hamming. I talk about him in the preface of the book. He is one of my heroes in computation, and I would encourage you to learn more about him. And so it's another way of gauging sequence similarity. The very first chapter was talking about tetranucleotide frequency, which just counts the number of bases that are present in a sequence. But we see here that these two sequences here have the same tetranucleotide frequency, but they're very different. So it's not necessarily a very good way of telling whether two sequences are similar. It can help us to determine if it's GC rich, which is another way of determining if two sequences have some sort of similarity. This one is more interesting though, because we're starting to get at position by position how similar two sequences are. So if we take these two sequences here, and they are of identical length, and we do, so we don't really have to align them because they are, if we just start from the beginning. But if we just start from the beginning, we see that there are just 3 bases in common, which out of 12 bases here, that gives these two sequences only 25% similarity. If we look further though, if we take these two sequences, they're actually, if we do an actual alignment, we see they are almost identical. We just need to shift one over or add an A to the beginning. But if we line them up starting from the left, then we see that they're only 66% identical. So this is not a great way of determining sequence similarity, the Hamming distance. This is what we're doing here on the right. On the left is more of an actual alignment, and which is far more difficult. Hamming distance is going to give us a metric for determining sequence similarity, and it's a fun exercise where we're going to talk about the ABS, absolute function, and bin functions. We're going to be talking about how to look at the elements of two strings of unequal lengths. If we look at the input here for the Roslin problem on the website, they are only going to give you strings of equal lengths. I'm going to make it a little more difficult with my test set and give you strings of unequal lengths so that you can consider mostly so that we can consider the zip and zip longest functions. I'm going to go a little bit more into map. We've seen map and filter and how we use lambda functions, but I'm going to show you how you can use other functions that already exist. We're going to also, some of those functions we're going to import from the operator module that you probably don't know about. And I'm also going to introduce you to another version of the map function called starmap, which comes from the itertools. So let's get started. If you are just coming into the directory here, you'll need to go into the base level directory and make sure you source the .dnv bin activate, because I am using a virtual environment here that I set up with UV. And if you don't know about that, go back to chapter 1 and read that, watch that first video. And so I'm going to start off by copying the first solution to our program, which is going to be called ham. Let's see, solution. Oh, sorry, I need to be in the 06 directory. I'm going to copy solution 1 to ham.py. And when I run this, it wants me to give 2 string arguments. And if I run it with -h, I get the longer. String 1 is sequence 1, and the second string is sequence 2. So that is what I want the help message to look like. And if we give this 2 strings, like these 2 right here, which I believe are from the example page, then it shows the answer of 7, which agrees with what the Roslin site expects for the answer here. So it seems like pretty straightforward. At this point, if you think you know what you want, how to solve this, I do encourage you to stop the video, use the tests here. We have PyTest -xv or vx, it doesn't matter. And if I run this, it passes all the tests, and we are not expected to read from files on this version. And in fact, here I go ahead and give you the very first part of the program. Pretty straightforward at this point. I think you could probably knock this out without too much help from me. But your argument class should have two sequences, seq1 and seq2. They are strings, and you should be able to set those up as two positional arguments. And once you have those arguments, I want you to tell me the Hamming distance, starting from the left. So if you want to go ahead, pause this video and go ahead and define your program, that'll be great. If you want to stick with me here, I will step you through how to go through this. One thing I would like to point out is that this takes two positional arguments, and so the way that they are defined in the code determines their position on the command line. And so it does matter which order you define your positional arguments. So if one is supposed to be, the name of an input file, and one is supposed to be the name of an output file, and you happen to reverse them, then you could end up overwriting your input file because you're thinking it's your output file, and then that would be very bad. So that is why they're called positional parameters, because their position is what determines their significance. I want to point out that the order in which you define the optional arguments does not matter. They can be in any order, and in fact you can put the optional arguments, you can define them before or after or both around the positional arguments. So just something to keep in mind when you're writing argparse here. These matter because they're positional. The optional arguments, the order does not matter, the order where you declare them. So with that, I'm going to go ahead and start from scratch. I'm going to, I have my line here. I'm just going to copy and paste this to start my program from scratch. And if I look at the ham that I have, I'm going to turn this into seq1 and seq2, and I don't need the other arguments. And so this is going to be, I think I'd call it seq1 here. It's going to be a string, and how did I define this? Sequence 1. I don't need the rest of these. And I can just copy this to be seq2. And I'm going to, even though in the book I show here just sending them positionally, where sequence 1 and sequence 2 are in the same positions as what's defined in the arguments, I do think it's better to always use the named version. So this will be seq2, seq2. And with that, I'm going to start off by getting my arguments and then printing args.seq1 and args.seq2. With that, I'm going to go into my directory here, and I'm going to execute my ham, make sure that I get a good help message, and then I'll say AAC and GGT. Let's see. And it says it got an unexpected argument. Let us fix this real quick. And for the eagle eye among you, you'll see here that it is it's saying it got an unexpected keyword argument. So it's a nice teaching moment here of seq2. And so I see here, yes, I am saying seq2, and I go up and I look at my class args and I see I made a mistake here. I have two slots called seq1. So if I change this to seq2, and this is the kind of safety that you get when you use named tuples instead of something like a dictionary, where it wouldn't care about the keys. And in fact, there it would overwrite the keys. Let's just real quick, I want to see what TY would say about this, about my ham program. Yes, and it actually, well, it finds here that it doesn't know what seek2 here. It says it's an unknown argument, but it's not actually complaining about the fact that there are two, that I've used the same name for the two slots. So that seems like that would be a problem. I'm just curious, let's see what Pylint has to say about it. And it is unhappy about my unused text IO. Okay, I can get rid of that. That's fine. And then let's see what else it has to say. Again, it's just claiming, it's just complaining about that args has no seek2. Maybe I mean to use seek1. Well, that actually gets at doesn't get at the real problem is that I duplicated the slot name. Let's try that again, and now everything is just fine. Let's go back to running our ham with AAC and GGT, and we see it prints our two arguments. Now, again, I just want to stress, why do we go to all of this trouble, especially for using argparse? We could very easily parse the two positional arguments ourselves using argsysv, sys.argv. But I don't want to do that for one reason. Here, if I throw another sequence on here, then it doesn't know what to do with it, and I get a nice error message telling me it doesn't know what to do with that last one. And if I only pass one, it says, well, there's still one more positional argument that is required. So it might even be, actually, it looks like it would probably be better to call this seek1 and seek2. And if I do that, when I run this, then it tells me the following argument is missing seek2. So it's very clear what's going on here. So I definitely encourage you, even for the smallest programs, to go ahead and use this structure, use argparse, because it's very common for a 10-line Python program to become a 50-line program, to become a 500-line program. And so if you start off with a good structure, it will make it easier for it to grow over time. So with that, we can now actually run a test and see what we're doing, how we're doing. We see here we are passing the first 3 tests just by virtue of having a decently structured program. But when it's passed, it's looking at it's opening an input file and it's reading 2 sequences and what's expected here. Then it's seeing that it's failing. Let's just look for a moment at the test inputs, and let's say vi test inputs 1.txt. What it's doing is it's reading these 2 lines of code, and then this be the expected output. So that's how I set up my testing script, is just to read the inputs and the expectations from an input file, which makes it easy to add more tests without writing too much more code. So this is what we need to actually make our program work. So how do we do that? Let's talk about how we iterate over the characters of 2 strings. And I do always really enjoy using the REPL. I think it's the secret weapon of Python. If you can also use notebooks. Jupyter notebooks are a great way to also play around interactively with Python. And there's also something called, let's see if I have it installed here, IPython, which is a slightly nicer REPL with maybe a little bit better history handling. And so any of these are all great ways of interacting with the language. I have a whole thing about why I don't like to write programs in notebooks, but I think that they're great for data exploration, and I definitely encourage you to try anything that makes you feel more comfortable with the language. Here I'm just going to stick with just the basic vanilla REPL, and I'm going to assign 2 sequences. This is that trick that I've showed you a couple times of defining a tuple on the right and then unpacking it into 2 separate values on the left, and that's going to become important. It's going to be another thing that I use in this chapter, is unpacking tuples like this. And like I said, I'm going to ask you to look at strings of unequal length, which the Roslin problem does not ask you to do that. And so right off the bat, these 2 strings are identical at the beginning, but I would have to either subtract two characters from this string to make it that, or I'd have to add 2 characters to this string to make it that. So the difference in their lengths, and we can use the len function on seek1 to find that it's 2, and the len function on seek2 finds it's 4. So if we were to subtract those two, then it will tell us the base distance from these 2 strings. And what we see is that we get -2, and that's not a distance. Well, we want the distance to be positive. And so as I mentioned in the beginning, I'm going to, I didn't mean to, sorry, I activated dictation. As I mentioned at the beginning, I'm going to use the ABS, the absolute function, to turn that into a positive number. So that's a nice built-in function that you may not know about. So I want to start off by assigning the distance, a distance variable, to be at a start the difference between the lengths of their strings. And they may be equal length for the Roslyn set. For the Roslyn inputs, they will be. So this will start off as a number of 0. And now I need to figure out how to iterate over the characters that are in common. So there are two characters that we need to inspect to see if they are the same. And so I can use the minimum of the lengths to find out how many characters I need to go over, and that's 2. And I need to go over the character from 0, 1, up to 2, and because of the way that, because we're using 0-based offset and all that, we're not actually going to use the second character, because that's actually the third character, the second offset. So I can do that with a for loop. So for the range for, and I am going to use I here because I is an integer value, and this is one of those limited instances where I think it's actually very typical to see this, and so you're really writing code in a way that other programmers would understand here. So the 2 sequences are AC and ACGT, and so the 2 characters they have in common are the lengths of the strings that they have in common are 2, and so if we iterate over those, we see A from the first sequence and A from the second sequence, and then C from the first sequence, and then C from the second sequence. So we see that is one way of iterating over the characters they have in common, and then we can determine if they are equal or not equal. And again, just pointing out that these 2 strings, ATTG and TTG, we can see right away that they only differ by 1 base. If we take away the A, then we'd get this string, but that is not the Hamming distance. We would probably intuitively say, well, the distance is just 1. But with the way that this is expected to be written, the Hamming distance is actually 3. Which is why it's not a great metric. It's not but it is a fun thing to program here. And so I'm going to now go into my solutions. So the first one is just taking those ideas, and if I put this into my program, I can create the Hamming distance. So I'm going to start off by unpacking those into seek1 and seek2. Little trick that I've used several times here. And then I'm going to take their 2 lengths. I'm going to do the same thing by assigning the length of seek1 and seek2 to the variables L1 and L2. And then I'm going to take the distance is going to be the absolute value of those differences. And then I'm going to do a for loop, and I'm trying to write this not to be so dense. So for the minimum of length 1 and length 2, I'm going to say if it's true that seek1 at this position is not equal to seek2 at this position, then I want my distance to go up by 1. So this really is all kind of code that pretty much we've seen before, and then at the end we're going to print the distance. And with that, let's see if this works. it does pass our entire test suite. So at this point, we're done. If you are just looking to find a solution and move on, you can. But I want to go a lot deeper into some of the things that Python can do for us. And so for that, I'm going to introduce a lot of ideas from functional programming, which is what I tend to lean into instead of object-oriented. I will not be showing you any sort of object-oriented solution for this. So with that, I'm going to show you how to, and we did this in an earlier chapter too. I'm going to take this, all of this is a nice unit, and it really belongs in a function that we can then write a unit test for. And you've seen this before, and I want to bring this in again. Even though it is definitely overkill, it is in the entire meat of the program. I'm going to move it into a function, but then I can have a test for it. It will be documented. It will be much easier to read. And so I would like to encourage you to start off by creating a function called hamming. And I like these little separators. I think it helps me read my code a little better. And so hamming, this is already looking like a pretty nice function just by reading the type definition, that it takes two sequences, they are strings, and it's going to return an integer, and I have a nice doc string right here, and I have a return statement. And with this, the first thing that I need to do is to create a test for it. One of the things that's very important about writing tests is that this function cannot print the answer. It needs to return it as a result. If you just write this function to print it, then you're not actually able to test it because you just can't. You need to return the answer and not print the answer. And this is going to be what allows us to write, for instance, this test here. Let me just copy it real quick, and I will paste it. Now I'm going to show you with the idea of test-driven development that the first thing that we should do is run PyTest on our ham.py program, and what we see is that our test hamming it dies right away. Now I'm only showing you with this book how to use PyTest. There's also unit test, which is another way of writing tests, and you are certainly welcome to explore that. I just found PyTest to be something that I was able to pick up very, very quickly, and it very much fits with the way that I enjoy writing code, but it's not the only way to write tests, and I encourage you to use whatever you like that fits with your brain. So with that, a couple things about the structure of my code so far. I still have all of this definition up at the top. I always like to put get args first so that when I'm reading the program, I can see very clearly, very quickly what are the arguments to my program. And then the very next thing I like to see after get args is main. I like for the main to be able to fit on, I like for really every function to be able to fit on a page. And I usually have about 50 lines of text, so I like to keep my functions to 50 lines or less. It's not always possible, but that way I can see the entirety of the main and what it's doing. And then I like to have all of my other function definitions after that. If I have a function and I write a unit test for it, I usually like for the unit test to come immediately after the function, and it starts with test underscore and the name of the function that it's testing. And that helps me additionally see how the function is supposed to work. So it's very important to me when I'm testing strings that I always send in the empty string. So when I send in two empty strings, I expect the answer to be 0. And that's a really good check because sometimes you just don't anticipate getting empty strings, and maybe your function will blow up if you actually pass them. So always a good idea to pass in I don't want to say bad values, but maybe unexpected values. and then put in a couple of things. I have just a couple of tests here that testing strings of unequal lengths that tells me, so I can make sure that I get back a good answer for that. And then these are two strings of equal lengths, and obviously there's a way more, many more tests I could write, but this gets at the idea. And when with test-driven development, I have a test. I have a function here that I know is not correct. It's always returning 0. And I have a test that proves that my function is not correct and I need to fix it. So to fix that, I can, for instance, take all of this code and simply move it into my function. And because I use the same seek1 and seek2, I don't have to rename them. And so what I'm going to be doing here is printing the result of hamming between arg seek1 and seek2. And so those are going to be passed in as seek1 and seek2. And then this should not have to change. The big thing here is that I don't print it, I return it. And now if I test this, let's see, what is it unhappy about? And so my test is failing. It's telling me that it's getting back 0 where it expected. It's trying to assert that 0 is equal to 2. It's getting back 0, and the answer should be 2. And it's yes, indeed, because I'm still returning 0. So if I change that now to returning the distance, I should pass my unit test, so I do. And if I pass it with a -v, I see a little bit more. It tells me the name of the test that's passing. Without the -v, it just puts a dot here for each test that it passes. And again, with as your programs become longer, you will have dozens of functions, I hope. Nice, short, defined functions and many tests to go along with them. And so nice to keep them into little units here. Another note here is that this function takes 2 arguments. As soon as you start getting into 3 and 4 and a variable number of arguments and maybe keyword arguments, I would argue that your function has probably gotten too complicated, and therefore your testing will get very complicated. And I would encourage you to break it into very small functions that take just 1 or 2 arguments, usually positional. I think that you will find that you can write tests very flexibly that way. So with that, I'm now able to run PyTest and run on my unit test that I have written. And so now my main function has become quite easy to read, very easy. So I come in here to main, I get my arguments, all of that argparse stuff happens to protect my program from getting bad, nefarious input. Once I have 2 sequences set up into a structure that I know is there, I can just print the hamming distance between seek1 and seek2. That is very clear code to be able to read, and when you come back to this program in 6 months, you'll probably be happy to see something that's quite easy to read. I want to show you another way of writing the guts of our hamming. So one of the things that's really crucial about composing your code like this is that now the hamming function has become this black box. And as long as it passes our unit test, we don't really need to care about what goes on in here. So if I write this program, this long program, it's got hundreds of lines of code, and I go through a code review and I see somebody suggests that some function needs to be rewritten. Well, as long as I don't change the way the function is called and what it returns, I can do pretty much whatever I want in the middle to try to find a better way of solving this, and it doesn't affect the rest of my program. So to that, I want to introduce the zip function. And this is another way of going over the elements that are in common between the 2 strings. And so to demonstrate this, I'll go into my REPL and I'll show you. Let's first look at just zip. If I try to zip these two, I get a zip object. And this is similar to what we saw with a reversed object and other generators that we've seen before. And as there are ways to coerce this into the values. The one that I typically use is to call list on these. And what we see is that when we pass it to two strings, A, B, C, and 1, 2, 3, A gets paired with 1 into this tuple, and then B gets paired with 2 into this tuple, and then C gets paired to 3 with this tuple. So I get 3 tuples of these matched up in their common positions. And so I hope that right away you see how you can use this to calculate the Hamming distance. What happens when we have two strings of unequal lengths, like the first one I showed you? Well, we only get 2 tuples. We only get the ones where there are in common. So if you were to start off with that base distance being the absolute value of the distance between the two strings, the differences, then you can then use zip to go over the rest of the characters, the ones that they do have in common, and figure out if they're equal or not. So, maybe pause the video here for a second. Using this information, how could you rewrite your function? If this is how I would do it, I can create a tuple for tuple in this list, and I'm going to show you a couple tricks here. So let me copy that again. First, I'll just show you when I do zip, this is going to give me this tuple, and I'm just calling it tup. I don't want to call it tuple because there's a built-in function called tuple. If I say help on tuple, it is a way of creating a tuple object, so very important that I don't say for tuple in zip. Sometimes I would also call this the element just t. Again, a very bad variable, but in this very small for loop, it would be obvious to me that t means tuple. And so when I run this, I see that I am printing the 2 tuples, and so I can use this trick that I've shown several times of unpacking that tuple into individual variables. And so without that, I might write something like this: char1 is equal to tup at 0, and char2 is equal to tup at 1. And then I would say print char1 and char2, something like that. A very, very longhand way of writing this. I can actually do that unpacking in the for loop, and you will see this quite a bit in Python code. And then let me just print that char1. So it is now far easier to read, and in many fewer lines of code to do the same thing. This is very common, and I would encourage you to write code in this way. Again, be careful not to use something like char, CHR, because that is a built-in function in Python. So using that, I could actually rewrite my function to be, first is the distance. The distance starts off as the absolute value between the 2 lengths of those sequences. And then I can use this for loop, for char in zipping the 2. If the character 1 is not equal to character 2, then distance goes up by 1. And then I return distance. And then let's just check our program. I'm going to run PyTest on the Hamming. I'll do it verbose. And I see that I'm still passing my unit test. Because I'm still passing my unit test, I should still pass the integration test as well. So, XV, I like to see all the test names. So I have now been able to rewrite my function using the zip function, and it hasn't changed anything else about my program. There is another way of zipping from the iter tools. Then you can import another function called zip longest, and as you can imagine, what this does is it creates tuples to the length of the longest string. So as I show here, if I import zip longest from the itertools module, then I'm going to get back 4 tuples, which is the length of the longer string. And for the positions in the shorter string where they don't exist, I'm just going to get a none value. We've seen none before. We've talked about the none type. It is just this way of representing missing data. You do not want, well, I guess in this limited instance you could have an empty string, but the empty string and none are different in kind of a weird way if you start really thinking deeply about it. So if I want to use this function, let's go take this and I'm going to import this. I always like to put all of my imports up at the top. Technically you don't have to. You can actually import something in the middle of a function. Not a great idea. Would not tell you to do that, but you can. And so when I write it like this, my distance actually starts off, let me go here, my distance is going to just start off as 0. And then instead of calling for char1 and char2 in zip, I'm going to use zip longest, which I can do now because I have imported it. And now my code doesn't, it's even shorter. The rest of it doesn't have to change. And I can verify that by testing that. And if I call make test is actually designed to also test the code itself, the ham Python script for any unit tests that belong in there. And additionally, I have here to run the flake 8 to see if flake 8 can find any problems with our code as well. So I can run make test to run the full test suite, and I see that I'm still passing. So just a slightly shorter way of writing this idea, and our code got, I think, a little easier to read, a little cleaner by bringing in a function that maybe you didn't know about before. So that is using zip longest. Now, part of what I want to show you here in all of these exercises is how similar these ideas, like I've shown you a for loop, and I have introduced before a list comprehension, and those two they go hand in hand. And I mean, you actually see here there's the for loop as the second part of this list comprehension, and we just sort of invert the for loop. So the for comes at the end and the meat of the for loop comes first. It can be a little challenging to read at first, and certainly this is, and it's going to get simpler and simpler here, but let's consider these two. Let me go back into my REPL. Let's consider these two sequences that we have from the Rosalind example. And the way that I'm writing this, let's concentrate on this. Let me just take this part. So I want to see a 1 if C1 is equal to C2, else I want 0. And I'm calling it C1 instead of char1, just simply so that it's less to type. So for the first character and the second character, in zipping the longest of these two sequences, give me a 1 if they're not equal, and else I want a 0. And if I run that, I need to go import that into my REPL here. And Itertools may need to be installed on your system, and it should have been installed with the setup with UV. So if I look at those seek1 and seek2, for each position along here, G and C here at the beginning are not equal to each other, so I return a 1. In the second position is an A, and in the second position here is an A, and so I return 0. And I hope that you can see, given a list of 1s and 0s, that I can call a function called sum on that, and that tells me the edit distance. That is the Hamming distance right there. So there's some fun tricks that we can use along here. One is that this is an if expression, and I've tried to stress a couple times the difference between an if expression and an if statement. So this is an expression where the value that you want to return comes first, the value for the positive, and then the else comes at the end. If you are coming from C or Perl, there's something called the ternary operator, and this is essentially the ternary operator in Python. It's just a little more verbose. So this is an if expression. Well, I can take this comparison and I can actually move it to the end in what's called a guard. And I've mentioned a guard before in a previous chapter. And so I only need to express the thing that I want for the values that match the guard. So this is a shorter way of writing this. And if I copy this and run it in my REPL, then I look at ones. Now I see I don't have this longer list. I only have a list of ones. And if I look at the length of that, then I see there's 7. And I can also sum them, of course, and I get 7. So several different ways of getting at the same answer, which is 7. So I have now moved the condition here in the if expression. I've moved it to the end, and this will only return the values in this for loop for which this condition is true. If you remember the dirty little secret that I pulled out in a previous chapter, that Booleans and integers are actually basically the same thing. Booleans are integers underneath. Then instead of returning 1 for C1, I can just actually return the comparison of C1 and C2. And so let's look at the difference of how that looks. So instead of so ones looks like this and bools looks like this. So this is saying, give me the comparison of C1 and C2, and we see here this is pretty much exactly the same as this ones, 1, 0, 1, 0, true, false. We see that it's essentially the same thing. And that means that I can, oddly enough, I can call sum on bools, and it will turn all of the true values into 1 and will give me the same answer. A handy trick for you to know when you're trying to count things is that you can filter like this and count the things that are true. So a shorter way, a much shorter way of writing our Hamming function is I can remove all of these lines of code and type this. Return the sum of comparing character 1 and character 2 for those characters in zip longest seq1 and seq2. Now that's a pretty tight function, and if I run make test on everything, I'm passing my unit test, I'm passing my integration test, and now it starts to look like, well, if we have a function that is only one line of code, then why have it in a function? And I would argue that this is, first off, not a piece of code that I would want to copy and paste throughout my program. That would, when you find yourself copying and pasting like that, then you pretty much, that's a sign that you need to make it into a function. I suppose if there was only one place in my entire program where I needed to calculate the Hamming distance, I might just put this in line. And that would make sense, except for the fact that when I have it as a function, then I can have a unit test. And if it's just a line of code inside a larger function, then I can't come up with a way of isolating that idea and testing it and documenting it and perhaps even ripping it out and finding a better way of writing that idea. So you have to take that with a grain of salt. When you're writing your own code, you get to make these decisions as to how you structure your programs. It's important to me that I went through all of that stuff about if expressions and guards and booleans and stuff, because when you are writing a list comprehension with a guard, you are essentially writing a filter function. So this will only allow the values to pass, to be expressed, to be produced if they pass this filter. This is a filter. And so we can express that filter with an actual filter function. And we have to get into a little bit of stuff I don't like about Python syntax here, because the lambda that I would like to write would accept char1 and char2 so that I can unpack them just the way that I can unpack them in a for loop, and then I could compare them, char1 and char2. But I am not allowed to do that because a lambda can only accept one positional argument. And that's fine. Zip longest produces a tuple. A tuple is one argument. So I can write it like this. Let's go in here and take, let's see, I think I've turned off, I think I jumped out of my REPL. So I'll go back in here, I'll define my two sequences, and then let's look at, first off, let's just take the filter part. I think you can anticipate what I'm going to show you here. If I look at filter, oops, I need to bring in the longest function from itertools, the zip longest. Do that again. And if I run my filter, I'm going to get a filter object that needs to be coerced. I can do that with list. And now I'm seeing these are basically these two bits here. The parts that what's being returned is the things that aren't the same. So given, let me clear that and run this. The lambda takes t, which is a tuple, which has a 0th position and a 1st position. And I say, just show me the ones where the first value in the tuple does not equal the second value, and it returns those two. So I have now written the same idea as the list comprehension with the guard. I've written it now in just one line of code using an existing function, filter, that we can just call on. And the weird thing here is that in many times you can use functions like len, and len will coerce it into the list, but in this instance it won't. I actually have to still call list, and I can call the length of that list, and I find that it's 2. So, which is true for those two sequences, AC and ACGT, the Hamming distance is 2. And so here is a way of writing this same idea. I can put that, and I'll put it into a couple lines of code here to make it a little easier. My filter takes a lambda, compares it to from zip longest, and then I'm going to return the length of coercing that into a list. And with that, I can run make test for everything, for my unit tests and integration tests, and I see I'm still getting the same answer, but I'm doing it with a filter function. So again, zip longest is going to return a tuple. The tuple goes into the lambda, and then the lambda takes the tuple and says, is the 0th one not equal to the first one, to the position? And only the values that pass this filter, this is the predicate here, this is a little function here, this is for the values that are, for which this is true, that is what's going to pass through the filter. And it's a little difficult to read because I'm having to negate it here. I generally like to write with a positive, but here we're looking for the differences, so we're going to use this negation here, not equal. And so the Hamming distance here is simply the length of the elements that for which this filter finds. Another, the hand in hand with filter goes map. And so filter only allows the values that pass the predicate to be produced. Map applies that function. It applies the lambda to the input values and produces a new list that has been transformed by that lambda. So they both take a lambda, but one applies the lambda as a filter and the other applies the lambda and then produces the values produced by it. So if we change this same function, if we change the filter from the function from filter to map, we have the same lambda. T0 is not equal to T1, and instead of producing this list, it produces false, false, true, true. Because when we say the first thing is not equal to A is not equal to A, well, that's false. C is not equal to C, that's false. None is not equal to G, that's true. None is not equal to T, that's true. And so we can get the same answer, a list of and let's go look at this real quick. I'd like to show it in the REPL. I need to remember this time to import that. And now I set up my two sequences. And what does this map look like? Well, I'm sure that you can know that that's going to give me a map object. So let me coerce that to a list real quick so I can look at it. This is another way of producing those true, false, all that. The same thing of comparing the two positions there. And so I can, instead of doing lists, I can sum that. And that is yet another way of finding the Hamming distance between those two strings. So again, the function becomes just a single line of code. And instead now we're expressing it as the sum over a map statement. And this is definitely functional programming. This is lots of little functions that take very restricted number of arguments, and we're piecing them together. We're composing them together into more complicated functions and programs. And with that, the way that we've written it, again, we run make test. We ensure that we are still passing all of our tests, and everything looks good. So I'm not happy with the fact that I can't unpack the tuple in my lambda, and it turns out that there's a function that I can use called starmap to do that for me. To build up to that, let me first show you that it's possible to assign a lambda to a variable. Now, PyLint does not like this. This is not Pythonic code, but let me show you that you can do this. And if I say, what is the type of not same? It is a function. I've assigned a function to a variable. It is almost the same as defining a variable and then putting this into it. And the one key difference here is that a lambda does not have to have a return statement, but a function definition does. And if I say, what is the type of not same? It's also a function. Underneath in the guts of Python, I'm not able to tell you how these are different, but I can tell you from a high level view that these are both functions. The thing about lambdas is that syntactically they really want to fit on one line, so it's very difficult to make, and it would be bad form to write a very long lambda that breaks lines. You'd have to put in backslashes and it would just become very unreadable code, whereas a function definition is supposed to have this code block and make it much easier to read. But there's nothing stopping you from assigning a lambda to a variable, and this is something you see a lot in JavaScript. It's something you see a lot in functional languages like Haskell and Elm. And so this is actually a very common way of expressing this idea in other languages, but Python really doesn't like to do this. It usually likes to just use the lambda as what's called an anonymous function. That's what a lambda basically is. And if you're curious, the lambda comes from the lambda calculus, which was the basis of a lot of computing ideas that we use. However you go about defining this, we can now call not same by passing it a tuple. And are these not the same? A and A, that's false. Are these not the same? A and T, that's true. It's true that A and T are not the same. And so what not same wants is it wants a tuple. And it's going to take that value and compare the thing in the first slot to the thing in the second slot. So with that, I can go back. Let's see how far back I have to go to find my, there it is. I can bring my zip longest again. I can go back to defining my lambda like this, not same. And now I can do something interesting. I can seek 1 and seek 1 and seek 2. I actually have to define them. Let me go grab a couple. Let's use these again. And so with that, let's see, missing required argument B. I cannot write it like this, not same with lambda A and B, because it's going to say missing a required positional argument. But what I can do is from the itertools, I can import another function called starmap, like this. I can define my two sequences like AC and ACGT. And then I can write starmap like this. And that does work. So going back, I've written now my lambda to accept an A and a B. And the thing is that the normal map cannot turn that in, it cannot expand the tuple into A and B, but starmap can. So it makes my lambda much, much easier to read. And now I can call that just by, instead of using map, I'm calling from itertools, I'm using starmap. And here's kind of a breakdown of what's going on here. Zip longest is going to produce AA, CC, none G, none T, and this not same is a lambda that now actually has A, comma B. It's going to take that tuple and expand it into variables A and B, and now I can just write A is not equal to B, which is a lot simpler than writing the way that I wrote it before with this T0, T1. That's really pretty ugly syntax. I think that's very pretty syntax. A, comma B, A is not equal to B. And so with that, I've now written a pretty nice little lambda. But wait, there's more. I don't even have to write this not same function because there is a whole module inside of Python called operator. And if I import the operator and I can say help on operator, and I think I've shown this before, there are a bunch of operators in here, like for instance, I think I pointed out add. So what does operator do? Operator add do? Well, add 4 and 5, and we get 9. So when I say 4 plus 5, it's actually underneath saying this is an operator. It's this one of these symbols that becomes between two values. It turns this into operator add and takes this first value on the left-hand side and sends it as the first argument, and this on the right-hand side and sends it as the second argument. So there is inside of here is there is a not equal operator. And it is true that 4 is not equal to 5. It is true that A is not equal to T. So this works is essentially, 4 is not, it is this operator. 4 is not equal to 5. A is not equal to T. And with that, it means that I don't have to even write my own lambda function and because all that was important to introduce starmap, because operator not equal needs two values. I can't use the regular map to map into operator not equal, but I can use starmap. So if we look at these two sequences, and then we call starmap on zip longest with not equal, it produces false, false, true, true. So yet another way of expressing this is to sum them, and because we know that we can sum this list of booleans and we'll get the value 2. So if I rewrite all of this right here, yet another way of expressing this, and the important part is that in addition to zip longest, I'll need to import starmap. With that, let me make test. And it's something, let's see, operator. I need to also import operator. There we go. So this really leans into functional programming quite a bit. And the point, what I'm trying to show you here is that none of these functions we had to write. Zip longest we brought in, operator not equal we brought in, starmap we brought in, sum already exists. So when you understand what the functions are that already exist inside of Python and you understand how to piece them together, you start to be able to write very powerful programs very quickly without having to write code on your own. These functions have been very, very well implemented and tested and documented. So really it's just up to you to learn how to use them. Again, I believe the best code is code that you don't write or have to test or document. You may think that this is overly clever, and I can appreciate that. I have many years of programming experience, and I'm very comfortable with these functions, and I feel that it allows me to move very fast in writing Python without having to write a lot of my own code. So with that, going further, I would suggest that you could write your own version of zip longest. Don't look at their source code, write your own. So start off with a program, maybe write a unit test, write some sort of a zip longest function that fails. Start from scratch and see if you can figure it out. Expand your program to handle more than just 2 input sequences. We have to get into in choose k numbers, and so for 3 sequences you'll have to put 3 distance pairs, and it gets harder from there. But you start to get into the idea of like multiple sequence alignment programs, of which there are many. And sequence alignment in general is just this incredibly complex, very deep subject that you could spend the rest of your life studying and implementing. So maybe try to write a sequence aligner and just see what it's like. It's crazy. And it'd be pretty much very difficult to write anything that would be performative in Python. I think you would see very quickly that Python would fall over for any seriously complex sequence aligner, which is, Python has its place in the world. A lot of times scripting is kind of a pejorative here. It's like a scripting language for writing small programs. You can actually write some pretty decently sized programs in Python. I wouldn't necessarily recommend it. I think Python has a perfect sweet spot for writing programs like we're doing here, and for pipelining and a lot of things. But it's important to understand where it has its limits, and working on extremely large, complicated data sets, it would probably prove too slow, and you would need to move to a faster language like Rust. And I will have a whole series of videos on Rust coming up from my Rust book called Command Line Rust. Anyway, to review, we were just trying to find the Hamming distance, and it wasn't actually that difficult. We came up with a solution right away, just looking at the distance between 2 strings and then iterating over with a for loop. And then we spent a lot of time going over lots of other functions to do the same thing. We talked about zip and zip longest. We talked about map and filter, and how they both apply a function to all the elements of a list, but filter only allows the things that are true for that filter, for that predicate, whereas map produces a new transformed list. We talked about that the function that you pass to map and filter can be this anonymous function that, just by using a lambda, or you can actually use an existing function like the operator not equal, or any function that you write or that already exists. You don't have to use lambda. I introduced the operator module, which is so good to know about, because we wrote operator not equal. Well, there's no point in writing that. We just use operator not equal. And finally, I introduced the star map. It is just like map, but it will splat the incoming values. So it allowed me to turn that tuple produced by zip longest into 2 separate values, which is exactly what I needed for the operator not equal. Okay, I hope you enjoyed that chapter.